Alright, Algebra 1, here we go. We're going to continue on 4-5, writing a function rule. We've been talking about writing rules, writing equations. We've been doing them for expressions so far, little smaller type equations. Now we're going to look at, basically we're going to look at word problems that you have to read, okay? Just because it's a word problem doesn't mean you can't do it. Just read it. Pull out the pertinent information. We've been working on this a bunch with our worksheets and word problems throughout the year. We're getting better at it. Just keep working at it. You'll get better at it. Okay? If you don't feel that you're quite there, it gets better. Okay? Our essential question is, why is it useful to write and solve equations that represent functions? Okay? It's useful because we can solve real-world problems. Okay? And we're going to look at a couple of them here. I'm going to pull a couple right out of the book right here, starting on page 280, problem 1. It says, we can estimate the temperature by counting the number of chirps of the snowy tree cricket. The outdoor temperature is about 40 degrees more than 1/4 the number of chirps the cricket makes in 1 minute. What is the function rule that represents this situation? So we don't need an answer other than what's the equation, what's the rule, okay? So let's kind of pull out the pertinent information that they give us. They tell us that the temperature is 40 more than 1/4 of the number of chirps in a minute. Okay? So I'm going to call temperature T. Is, we know, means equals. 40 more than, you're going to add 40. So it's 40 plus 1/4 of means to multiply the number of chirps in a minute, which I called N. So if we knew how many chirps in a minute, or if we knew the temperature, we could backdoor it in. Either way, we could solve for T or N, knowing one or the other. Okay, but that is the function rule, the equation to solve that. Okay, problem 2. A concert seating plan is shown below. And you can follow this. It's on 281, it's in your book. Reserved seating is sold out. Total revenue for ticket sales will depend on the number of general seating tickets sold. Write a function rule to represent this situation. And then what is the maximum total revenue? Okay? The total revenue is the general revenue plus the reserved revenue. If you look in the book, you'll see in the problem there's 2 different sections of seating. Okay? In the general, it tells you that the reserved is sold out. So you know you sold 10 rows of 12 seats in each row, 120 tickets at $25 a piece. It tells you that in the problem if you look at the diagram. To start with, we don't know the number of seats sold, so I can call it N. The revenue would be 10 times N, the number of general seating, because it's $10 per ticket times the number of tickets, plus what we get out of the reserved revenue, which was sold out, 25 times 120. Now if you want to know the total revenue, if it's sold out completely, there's 30 rows of 16 seats, so that's 480 seats, so that N would become 480 because that's all the seats that they have in the general. And when you multiply and you add them up, you find that you're going to have a total revenue of $7,800. $10 for every ticket sold here, $25 for every ticket sold there. Multiply and add. Okay? Very straightforward. Nothing really different than what we've been doing. We're just putting a little bit more focus on writing the rule, okay, getting the equation. Most of you are okay once you get the equation. Problem 3 on 282. It says write a function rule for the area of a rectangle whose length is 5 more than its width. What is the area of the rectangle when its width is 9? Okay? So, area of a rectangle is length times width. That we know. The length, it tells you, is 5 more than the width. Find the area when the width is 9 feet. That's what they want you to find ultimately. Diagrams are worth 1,000 words. A picture is worth 1,000 words. You've heard that before, so use it. Draw a rectangle. I always call the length the longer side, the width the shorter side. They tell me that the length is 5 more than the width. Well, I don't know the width, so I'm going to call it W. Whatever it might be, it's W. Well, then my length has to be W plus 5 because it's going to be 5 more than. So you're going to add 5 to the W. So in terms of W, I now have my area. Length times width will become W times W plus 5. That's length times width. And when you distribute, you get W squared plus 5W. That right there, that's my function rule, okay? That's my rule, my equation. Then it went one step further and it said find the area when the width is 9 feet. So plug in 9 for the W. So I'm going to get 9 squared, 5 times 9, 81 plus 45. It's 126 square feet because it's feet times feet. Okay, area is square feet, volume is cubic feet. So there's 3 examples. Read the problems, come up with the equation. If they ask you to find something using that equation, then finish it up with that. Okay? We've been working on these all year in our worksheets, thinking about a plan. We're going to continue to do this because this is the practical application of the mathematics that we use in this class, and you're going to see it a lot on the end of course exam. So we've got to be ready for that. Okay? 4 or 5, we're going to look at this some more in the classroom, continue doing word problems as we go. Hopefully this has been helpful, and we'll get after some of these tomorrow. All right, see you then. Have a good one. Bye.